Okay, good afternoon, good morning, good evening, wherever you are in whichever part of the world. Welcome to this particular session of the Stockholm World Water Week, where we are a bunch of IPCC authors who contributed to the latest Working Group 2 report. And today there are eight of us. I need to, there are some 7 of us here today who would be bringing up the various aspects of water that we covered in this assessment cycle of AR6. My name is Dr. Aditi Mukherjee, and I work with the International Water Management Institute. I'll start the presentation, and at the end, I hope we would have some interaction and question and answer session. So we would be tracking the chat on the CV website that we all have. Yeah, welcome. I hope we have some good interactions and question and answer at the end. So to start, as I said, that this is about water-related findings from the IPCC assessment. The way we will do, so just to give you a brief overview on why we think water is important, though it's almost like talking to an audience that already knows, given all of you are attending the Stockholm World Water Week. So climate crisis is also water crisis. Water is largely neglected in climate change negotiations. I recently learned that water does not even feature once in the Glasgow Pact that we had last year, not even once. So that's a gripe that I have. So climate change has led to changes in all components of the water cycle. Richard will talk about that, which has resulted in negative impacts in almost all the sectors and also in some of the among the most vulnerable people. So we have speakers, lead authors from the Africa and the Asia chapter, and the lead author from water who will talk about some of these impacts. Also the fact that almost majority of the adaptation that this cycle assessed actually were about people were adapting to water related changes. Almost 60% of the adaptations were for hazards related to water, such as floods, droughts, etc. And the adaptation themselves were also using water, for example, use of irrigation for livelihood, soil moisture conservation, and so on. And also, interestingly, what's also there in Working Group 3, but also in Working Group 2 is around that many of the mitigation measures, including the nature-based ones, such as afforestation or some of the other ones like bioenergy crops, etc., also have water imprints and water implications, which are rarely discussed. So with that, I just wanted to introduce the entire panel and speakers. So today we have with us Professor Richard Betts, who led the water chapter, was a lead author in the water chapter, and Richard will talk about the impacts of climate change and the hydrological cycle. Richard will be followed by Dr. Chandni Singh. She led the Asia chapter. She will talk about the water impacts in Asia. Then followed by Dr. Edmund, who would talk about, he led the Africa chapter and will talk about water in Africa. Then we have Dr. Shobha Maharaj. She was a lead author for the Small Islands chapter. Shobha will talk about the water-related impacts in small islands. Then Dr. Martina Careta, who was CLA for the water chapter, she will talk about the impacts on marginalized group. Then Tabia and I, Dr. Tabia cannot be here today for another, she had another urgent meeting. So Tabia and I, both of us were in the water chapter, and we will talk about how water is important, not only for the current adaptation, but also for future adaptation, and how water, basically in a warming world, many of these adaptations will not work. Then I'll also follow up briefly with the implication for mitigation. And last but not the least will be Dr. Lisa Schipper. She led the chapter on climate resilient development, and Lisa will talk about how water can also play a role in the climate resilient development. So with that, I invite Professor Dr. Richard Betts to present his slides. Richard, you can ask me to change slides as we go along.
Okay, thanks, Aditi. Yeah, so one of the key conclusions from the whole IPCC Work Group 2 report, including the water chapter, was that we're seeing the impacts of climate change already across the world in all regions. And many of these impacts do relate to water. And one way of illustrating this is just how people are seeing changes in precipitation. So people are seeing changes in rainfall and snowfall in different directions across the world. So this map shows the number of people in each grid square, which are seeing increased precipitation in green or decreased precipitation in the brown colours. And the chart on the table on the right shows the total global population seeing either decreased or increased rainfall. You can see that 163 million people are seeing drier conditions now. So the signal of drying is emerging and is being seen by 163 million people across the world, but nearly 500 million people are seeing wetter conditions, 498 million. So that signal of change is clearly being picked up and is clearly being experienced by people across the world. Next slide, please, Aditi. Thank you. So we are also seeing changes in heavy precipitation. I just showed the average precipitation previously, and the signal of that is actually even clearer. And there's very good physical understanding behind why this is caused by human-induced climate change. It's well understood now that a warmer world caused by increased greenhouse gas concentrations leads to heavier rainfall on the whole, although changes in atmospheric circulation patterns do bring less rainfall in some regions. So in terms of the global numbers, 86 million people are seeing less heavy precipitation, but over 700 million people worldwide are seeing more heavy precipitation. And we know that human-induced climate change is the main driver. And as an example, we can actually now attribute individual extreme events to climate change. We can see that the conditions that led to these events, such as flooding and drought and so on, we can see how much climate change has affected the magnitude or the likelihood of them. And one example is the flooding in Western Europe in 2021, when over 200 people were killed, and there were billions of euros of losses across Germany and Belgium and nearby countries. And it was found using the climate models that the daily rainfall that was related to that flood that caused that flooding, that was increased by up to 19% by human-caused climate change. So that was an impact of climate change clearly playing out there. And there's many other examples of that now as well on flooding due to heavy rain. On drought, dry spells is more complex. We're seeing, yes, that's the one. Thank you. It's more complex. Many areas are seeing increased dry spells, so the length of time without rain, but some areas are seeing a decrease in dry spells in terms of the rainfall, but I'll come into a complexity of that in a minute. But across the world, 700 million people or more are seeing longer dry spells, so periods without rain. 400 million people are seeing shorter dry spells. So on balance, more people are seeing more meteorological drought, longer dry spells than shorter dry spells. And as an example of an event attribution study, in 2017, there was an extremely severe drought across East Africa, which led to near famine conditions. And it was found that the low rainfall conditions there were made twice as likely by human-caused climate change. So next one, please, Aditi. Thank you. So the important point, though, is not just about the rainfall, it's also about evaporation. So a warmer climate causes more evaporation, drawing water out of the landscape and reducing the water available in the soil and the rivers. So droughts can actually be made more severe by warming. And actually, the signal of that is more clear than the change in rainfall. So even places where the rainfall is not decreasing, we're seeing more severe agricultural and meteorological drought because of the increased evaporation. So an event attribution example here in the USA in 2017, there were huge losses and huge wildfires as a result of this drought, which was due to increased evaporation. And it was made 1.5 times more likely by increased evaporation, even though the anthropogenic impact on rainfall was not seen. It was an evaporation caused drought. Next one, please, Didi. Thank you. So, so we're seeing these impacts already, and we expect to see many of these to become more severe on the whole in the future. Although some may become less severe depending on what the global climate is doing. But on balance, we're seeing more an increasing severity with in the projections with ongoing warming. So this map shows the average from multiple climate models showing the frequency of flooding from heavy rain, and it's the change in frequency compared to the present day. So blue areas are showing an increased frequency of flooding and red showing a decreased frequency of flooding, and the black dots show where there's a consensus between the models. So where there aren't the black dots, there's disagreement between the models. So you need to be aware that there's still uncertainty here. But you can see many regions such as the Indian subcontinent, Southeast Asia, Central Africa, and so on, are seeing a projected increase in the frequency of flooding, whereas Eastern Europe, Northwestern Asia are seeing projections of a decrease in the frequency of flooding. That's with the low emissions scenario by the end of this century. So that's just below 2 degrees global warming by the end of the century. If we go to the next slide, please. Thank you. This is with the medium emissions scenario, which is about 2.5 degrees warming by the end of the century. You can see the same general pattern of change, but with more intensity. So where there's increased frequency of flooding, that gets even more frequent. Where there's decreased flooding, that gets even less frequent. And the consensus tends to increase as well. There's more black dots there showing the agreement between the models is increased as well. So we get more certainty at high levels of global warming. And the next one, please. Thank you. So with a very high emissions scenario, which is about 4.5 degrees global warming roughly by the end of the century, again, the same signal is seen, but again, stronger. And you can see that in the places that are seeing an increase in flooding, the flooding frequency, which was 1 in 100 years currently under the current climate, would be almost happening every year in many parts of the world. So really large increases in flood frequency in some places. Next one, please. Thank you. And then finally, on future projections of drought, it's a similar story, really. Some areas are projected to see a decrease in the likelihood of drought. This is slightly different. This is the likelihood of drought as opposed to the frequency. And it's at levels of global warming. This is at 1.5 degrees global warming. So where it's green, there's a decreased likelihood of drought. Where it's orange, it's an increased likelihood of drought. And we're talking about agricultural drought here. So soil moisture droughts are affected by evaporation as well as rainfall. Some areas are projected to see a decrease in the likelihood of drought, but many areas are projected to see an increase in the likelihood of agricultural drought. That's a 1.5 degrees global warming. Next one, please. Again, that's magnified at 2 degrees global warming. So you can see that much of North and South America is seeing a more than 150% increase in the likelihood of drought. For example, in Southwest Europe, the Iberian Peninsula, over a 200% increase in the likelihood of drought. And next one, please. And again, as you might expect, high levels of global warming, these become even larger. So we get very, very large increases in the likelihood of agricultural drought across many parts of the world. Decreases in some parts, but you can see the overall change is more towards an increased likelihood of agricultural drought, especially at high levels of global warming. And that's it from me. So I'll hand on to Chandni now. Thank you.
Yeah. Thank you, Richard. Over to you, Chandni.
Thanks so much. All right. So I was a lead author on the Asia chapter, and I'll be presenting some findings from that, really focusing only on the impacts of climate change on water, but also a bit about how it intersects with vulnerability and existing inequities. So these are the three main messages really that are there around water, I think, from the Asia chapter. The first is that from some of the maps that Richard showed, you can see that Asia is one of the most exposed regions in the world when it comes to climate change, and also both in terms of the intensity and frequency of hazards that are going to be seen, but also the numbers that are at risk, the number of people that are at risk to these hazards. The second big finding, I think, is there is this story that one can tell through water of either too much water or too little water, where you're seeing increasing evidence of droughts, as Richard was showing in these last few maps, but also a story of sea level rise and increasing flooding, especially in coastal areas. And of course, this idea of too little and too much water, they flow over, I would say, underlying or structural vulnerabilities that are there, both in rural and urban areas across Asian countries. So this leads to a sort of unequal story of risk and impact, risks being future and impacts being the current impacts that we're seeing. But there's also the simultaneous, just the last point, Aditi, the simultaneous recognition that various Asian countries and cities are actually adapting. So there is a lot of evidence for this, but most of that tends to be incremental, and it's still inadequate to the kind of risks that Asia sees. Next slide. Just to give a bit of, I just put this out there to say that, of course, the Asia chapter covers 53 countries, if I'm not wrong. So it's a large scope, and that's why some of these findings are quite generic, but the evidence is really pulled out from these different parts of Asia. So that's the breadth of the chapter. I'll go to the next slide after this one. Yeah. So after this, you can just go to the next. I don't want to talk through this one. All right. So
am I on the correct one? Sorry. Yeah.
No,
is this
yeah,
the one?
this is fine. Yeah. So
Okay,
this is what the working group 1 actually says, which is the story of both average and heavy precipitation is going to increase over much of the Asian region. Relative sea levels are going to be increasing, and the rate of that increase is going to be higher than global averages in recent decades. And this also intersects with the loss of coastal areas and retreat of shorelines. So when thinking of these trends, I think it's important to recognize that a lot of Asian cities and settlements are actually in very low-lying areas and coastal areas. So there's a very real implication of some of these projections. Also, some of the small islands in particular are going to face more intense and frequent cyclones. I think others will speak to this a bit more. And then there is this very clear evidence around glacial melt, changes in seasonal snowfall, and the fact that especially in the Russian Arctic, how permafrost is thawing and is going to decline further by 2050. So there are high confidence around all of that. And the ripple effects of that is, of course, with glacial melt, especially in the Himalayan region, there's very clear evidence to say that first, there's going to be an increased runoff. So rivers are going to see more water. This is the Indo-Gangetic Plain across the Indian subcontinent. And then towards the middle and the end of the century, there's going to be less water. So there's going to be a lot of fluctuation in water availability across the Indo-Gangetic Plain. And then there's a less known, less spoken about thing around marine heat waves. So while we talk a lot about heat waves in land areas, but there's also going to be marine heat waves. And I bring this up just because we tend to forget about the oceans when we're talking about water. So I just wanted to mention that. Moving on, you can just click through for all the, I don't know why it's animated like this. So these are just some of the, again, the high confidence findings from the Asia chapter. First of all, I won't talk so much about the heat, but maybe focusing more on water scarcity. Again, as I said, the implications of changing snow and rainfall on food systems and availability of water is quite significant. And this is one of the key findings where at higher warming levels beyond 1.5 degrees, so at 2 degrees, regions that are relying on snow melt can experience a 20% decline in water availability for agriculture after 2050. There's also a slightly less spoken about finding, I think, around drought that is not only rural, but also going to be seen in urban areas, and that has cascading impacts on peri-urban and rural areas. So when cities are experiencing drought, they tend to extract water from other areas. So this idea of risks are going to not only stay in one place, but going to be cascading out. Of course, this changing water availability is also expected and is already having impacts on food security. And there are some examples from the Asia chapter on particular staple crops that are going to be affected. And especially when you look at water scarcity and heat coming together, or just changes in temperature. So warmer winters and extreme high temperatures in spring and summer, that's really going to have, again, a compounding effect on crop yields and therefore food security. And then finally, the story of too much water, again, to highlight that 12 of the top countries, top 20 countries that are exposed to sea level rise, if you just look at the numbers, are actually in Asia. And some of these countries are also they're very densely populated. So the numbers of people that are going to be exposed is also very significant. Moving on. Yeah, we can move on. Maybe I'm just a little concerned about time and I want to get to my last slide. So we can carry on. These are just some maps, and I think people are interested in going into maps around flooding, cyclones. This one is around drought. There's lots of granular data that they can get into, I think. So if we move on. This is something I wanted to highlight, that we often talk about what are the impacts of too much water and too little water, and what are the implications of that on human and ecological systems. And this is an assessment that the Asia chapter did on some of the climate-induced losses and damages around whether it's sea level rise, coastal flooding, heat waves, and so on. And you see that, of course, in the past, and this is something I want to highlight repeatedly, is that in the past, we've already seen losses and damages occurring. So it's not something that we are waiting for the future to see. Of course, that differs across different parts and subregions of Asia. But in the past, we do have evidence of climate-induced losses and damages, and that, of course, with higher warming levels is only expected to increase. There's much less evidence, at least in the literature that we reviewed, around non-material losses and damages. So we tend to talk about cyclones affecting road infrastructure, power supply going down, for example, but there's less evidence on perhaps the loss of a certain livelihood, a way of being able to fish from the sea. Those kinds of more intangible losses and damages need a lot more research. And then my last slide. So while I've spoken a lot about these hazards and what they mean perhaps for certain sectors, I do want to highlight that a lot of the chapter devotes time to say that Asia as a region is, you've got some high income countries, middle income, and then a vast set of countries that are quite low income. And so there's a lot of uneven development going on in these countries, and that is really the bedrock on which then we are seeing climate change. There are also countries that have, so there are different, what should I say, different priorities that nations have to meet these development or overcome these development deficits. And that is something to keep in mind, I think, when we start moving from climate impacts and risks onto adaptation. I'll stop there. Thanks, Aditi.
Thanks so much, Chandni. I'll now ask Edmund to present some of the, sorry, I should have changed this to Africa when I included your slides, but Edmund, over to you for the Africa related findings. Yeah.
Thank you, Aditi. Yeah. So, well, this is one of the key messages from Africa chapter, where we see that water scarcity and hydrological variability has cascading impact, and not only on water, but also has an interplay with health, economy, food productions. And next slide, please. We see that Africa has contributed very little to greenhouse gas emissions, but although we face a serious loss and damage in different sectors, as I said, please, next slide. And yeah, and when we talk about water, it's a serious issue in Africa because 95% of food production, crop production specifically, is rain-fed. So whatever affecting water has implication on food availability and, of course, economic and health, a loss of biodiversity, and increased human morbidity and mortalities. And the water issue is more serious in Southern Africa and and North Africa. And we have a specific case from Cape Town, or one of the places in Tanzania in 2018, showing how serious water issue is in Africa. Please, next slide. Yeah, in terms of projected impact, we have extreme hydrological vulnerabilities projected to progressively amplify on the future climate scenario, and there is a high agreement around that, no doubts on it. And in terms of how it happened, please next slide. Yeah, so we see that many African cities are facing increasing water scarcity, and this have to do with decrease in rainfall, but also the increase urban populations in most African countries, where we see, for instance, that's a country like Nigeria or Ghana, where the urban population is increasing rapidly, which means that the water demand is also increasing. As I already indicated, Cape Town in 2018, it's a really illustrative case of how water can be a challenge to countries. And this is supposed to increase in many parts of Africa. And we see also that the projection of number of people exposed to water stress is widely vary across the countries, and it can be up to 921 million additional people in sub-Saharan Africa by 2015. And yeah, there is no clear pattern of how this is going to affect West African countries. We see that it's in Southern Africa or North Africa. There is more or less a clear consensus on how the future risk will be. But in West Africa, this can be because of data availability, and also, yeah. Please, in terms of adaptation options and how people try to cope with this, we see that in terms of planning, we need more a system planning approach to how we manage water infrastructures. It's not only about planning for water, but how we take into account these intersections with other dimensions, food, health, as I already indicated. And the promotion of waterless on-site sanitations, and this is a highlight in the report as well, something that can contribute, because we said that urban population in Africa is increasing. And in many regions, we see that rainwater harvesting infrastructure is widely used. And in the assessment we did, this is proven to be kind of effective adaptation option, because it's used at small scales. It's people at local community have capacity to maintain those infrastructure. In early 1980, there was large infrastructure, irrigation infrastructure that were developed across many countries in Africa and to promote food production, but remain those infrastructure were quite hard for people to maintain. And in terms of impact, in terms of effectiveness, we didn't see so much change. And water recycling, this is also seen as a kind of promising options to consider in Africa. Unfortunately, yeah, this will be my last slide, if you allow me. Yeah, this is my concluding word. Yeah, the water recycling option is not so much widely used across Africa, but we see a potential on it in terms of building resilience in water systems as urban, mainly in urban area, because urban populations is going to increase. So this is something we can promote. Yeah, so that's all we have from Africa chapter in terms of water related message. Thank you, Aditi.
Thanks, Edmund. That's really good, especially around the part around, you also touched upon the adaptation options. Thank you so much. May I now invite Dr. Shobha Maharaj to talk briefly about the impacts on small islands?
Hi, everyone. So there are two points to keep in mind when it comes to small islands and water. First of all, freshwater systems on small islands are exposed to dynamic climate impacts, as we all know, and they are amongst the most threatened on the planet. Secondly, small islands are small, and so that means that the ecosystems across these islands are very closely connected, And therefore, for example, changes that are happening on land, be it climate or human-induced, often rapidly and directly impact these freshwater ecosystems, their services, and hence the human populations downstream. Next slide, please, Aditi. So when it comes to water security within small islands, this is impacted by multiple drivers, with some of the main ones being drought and sea level rise. There are also multiple impacts that stem from these, such as increasing water insecurity, decreasing agricultural production, and hence decreasing food security, as well as increasing negative health impacts. And just to briefly share a bit on each of these, when it comes to drought and aridity changes, the Caribbean and the Pacific regions have historically been affected by severe droughts, and already significant physical impacts and negative socioeconomic outcomes are being experienced across many SIDS. Impacts include decreased water quality and water availability. For example, the El Niño-related 2015-2016 drought in Vanuatu eventually resulted in residents having to rely on just small amounts of contaminated water left at the bottom of their household tanks. Additionally, rainwater harvesting has also been impacted by drought across both regions, the Pacific and the Caribbean, especially in rural areas where connections to centralized public water supplies are already very difficult. Research in Jamaica, for example, suggests that rainwater harvesting to meet potable water needs between the 2030s and 50s will be much reduced. And other drought risk projections aren't encouraging either. So for the Caribbean SIDS, projections aligned with observations from the SSP2 scenario indicate that a 1 degree increase in temperature could result in as much as 60% increase in the number of people projected to experience severe water resources stress from the 2040s to the 2070s. And moving on from droughts and changes in aridity to sea level rise and its impacts on freshwater lands, this is a real and growing concern with respect to many small islands. Research is suggesting that managing the risk of salinization of freshwater resources will become increasingly important to many small islands. Evidence suggests that on some small islands, the availability of fresh water is already being impacted by compounding effects of sea level rise, coastal flooding, tropical storms, and cyclones. A good example is the estimated 11 to 36% reduction in the fresh groundwater lens volume of some small atoll islands of the Maldives due to this. And in some cases, even small overwash are already leading to saline conditions that last for up to 3 months. In fact, in some Pacific atolls, projections indicate that freshwater resources could be significantly affected by sea level rise of 0.4 meters. And similar impacts are also anticipated for some Caribbean countries. There is, in fact, quite high confidence that such changes will in turn affect ground and surface water resources for drinking, irrigation, and similar across these regions. Also, with the small island situation, the combination of coastal zone areas with population growth is particularly important. First of all, the freshwater lands within coastal zone areas tend to be thinner and are most likely to be impacted by multiple climate stressors such as tropical cyclones, hurricanes, sea level rise, overwash, etc. Added to this, on many small islands, coastal zones also tend to be where human populations are likely to be the most concentrated. And it has been shown that population growth plays a strong role in projected future water stress. Research combining changes in aridity together with population growth derived from the SSP2 suggests that SIDS with high projected population growth rates are expected to experience the most severe freshwater stress by as early as 2030 under a 2 degree Celsius warming threshold scenario. Then there's agriculture. These impacts are also leading to increasing food insecurity as agricultural productions become increasingly impacted. For example, in the Caribbean, it's been projected that additional warming by 0.2 to 1 degree Celsius could lead to a predominantly drier region, which would of course lead to increasing occurrence of drought along with associated impacts on agricultural production and yield across the region. And food prices, quality of life, poverty levels, etc., are all expected to be negatively impacted. And then there are other negative spin-offs such as health. There's heavy reliance on aquifers and rainwater harvesting in small islands, particularly atolls. Coupled with overcrowding, population growth, and contamination, the risk of waterborne diseases increases as warming continues. For example, seasonal rainfall in Kiribati is associated with waterborne diseases such as diarrhea, cholera, typhoid fever, and future projections indicate increases in the number of days of heavy rainfall by 2050, thereby suggesting future increases in risk for these diseases within heavily populated areas. Also, damage to water and sanitation services can cause infectious disease outbreaks, such as the cholera outbreak that occurred in Haiti following Tropical Cyclone Matthew. Next slide, please, Aditi. So just quickly on adaptation, just some general points. While there is a range of adaptive measures that are currently underway across many small islands, these are often incremental and do not match the scale of extreme or compounding events. Much of the current adaptation measures tend to be small in scale, for example, community-based adaptation projects, sectoral in focus, and do not address the structural and systemic changes that are needed to combat climate impacts and achieve long-term sustainability of adaptation interventions. Additionally, specific barriers to effective sustained adaptation within the water sector on many small islands include variable climate change awareness amongst decision makers and the preference for short-term responses rather than longer-term transformative change. Barriers also stem from donors preferencing their own priorities that do not necessarily fit the country's priorities or context. Also, many climate change initiatives across small islands tend to be unidirectional in focus, and they focus on climate risk and they tend to shift limited resources away from other important development objectives, which of course leads to positive feedback loops. In particular, local level plans are often overlooked, and this is quite a widespread issue. For example, in the Caribbean, there's difficulty transferring funding from central to local government levels. And in the Mauritius, local level climate adaptation plans are currently nearly non-existent. And so with this not so positive note, I will end the small island synopsis. Thank you. Back to you.
Thanks so much, Shobha. I now want to pass on to Martina, who will talk more specifically around the impacts of vulnerable groups. Martina, given the time constraints,
Yes.
keep it. Yeah.
Yes,
Okay.
thank
Yeah.
you.
Over to
Thank you, Aditi, and hi, everyone. Thank you for having me today. So in this presentation, I will focus on what we covered in our chapter as it pertains to marginalized and vulnerable groups and how they are impacted by hydroclimatic changes. So if we've looked specifically at two groups, you could say, indigenous peoples and women. So I'm going to be presenting on those two today. Indigenous peoples have not been taken into account when it comes to governance and planning in relation to climate change impacts and adaptation. And this has been due to a history of colonialism and capitalism that has been exacerbated by issues around dispossession and disruption. Indigenous knowledge has generally not been taken into account when it pertains to mapping impacts and also thinking about how adaptation should be planned. And when that has been done in international context or by NGOs or even by scientific research, indigenous knowledge has tended to be actually tokenized and taken into account mostly for reactive management practices or strategies rather than long-term planning. What we've seen also in the presentations that have come before mine is that many of the changes that we see in our climate are irreversible. And if we think, for instance, about the case of the cryosphere, of melting ice and glaciers around the world, these are actually irreversible, and they impact indigenous population in a particularly harsh manner, because the pace and the extent of these changes are challenging the ability both of the natural and the social system to adapt. And this goes together with the risk with the compounding risks. Aditi, next slide, please. When it comes to women, what we have seen is that impacts in practice for them, and I think here there's actually a slide missing. But okay, I'll pick up on that slide without actually yeah, okay. Go back to the slide that you were showing. What we see is that women experience in generally more limited access to resources, both in the global south and in the global north, when in relation to land, technology, finance, and financial literacy. They have a very limited access to decision-making forum, a generally lower level of education, and less time to access financial services, to get an education, because they have to take care of lots of household responsibilities. This goes together in the global south, particularly with a higher dependency on nature-based livelihoods. So what we see when it comes to water and the impacts related to hydroclimatic changes and adaptation is that the fact that women are excluded from decision-making forums when it relates to water management puts them at higher risk, and also make them face more impacts. A typical example that is given as a proof that women are highly vulnerable is that they walk, many of them walk several hours all around the world to fetch water, and the time that is expected that they will have to use around this practice is actually going to increase in the future. What does this mean? Is that more time to get water that is farther away means less water that is going to be collected, which means having to resort to limit hygienic practices, for instance, or washing, cleaning, but also cooking. When water scarcity is experienced in a household, there's a lot of evidence that shows that this actually increases domestic violence, because tasks at home are not being completed because time is spent to go fetch water. And also the fact that water can't be collected and the food can't be put on the table due to water scarcity has several pieces of research has shown that these have a direct impact on the increase of child marriage. What all the previous presentations have shown is that water scarcity is going to, whether in water insecurity, whether in the form of floods and droughts, is going to impact substantially agriculture. And what we have to keep in mind is that the majority of people employed in agriculture in the global south are actually women. So what we see on one hand is that women are the most vulnerable when it comes to water insecurity, but they're also the ones that are at the forefront of where adaptation could actually be taking place. Next slide, Aditi. Going back to what it means to be faced with water insecurity. One element of that is the access to water and sanitation and hygienic infrastructure that is lacking in most countries in the global south. That compound with hydroclimatic changes actually puts women at a higher risk for psychosocial distress, gender-based violence, lowering of hygienic standard, and also a higher risk for maternal and child health. Women generally has been seen, again, mounting evidence here, that have a lower chance of surviving disasters. They're less taught to swim, for instance, which is very much needed in the case of a flood. And as the previous examples that I gave show, they're much more prone to malnutrition, sexual and domestic violence. When water scarcity happens, what we see as we can discuss this, but in some cases has been presented as an adaptation strategy to migrate. What we see is that often men are the first ones to migrate. And what does this mean? This means a heavier workload and a heavier caregiving burden onto women that are left behind. Next slide. Here I'm presenting a graphic that we have in our chapter. I put the link in the chat so you can download the chapter from there and look at this graphic more in details. But basically what this graphic shows is that are examples of indigenous populations around the world and how they have been impacted by hydroclimatic changes. We've been able to map them across almost all continents. And what we see in our chapter is that cultural, there are different meanings attached to water, not just a productive meaning or a reproductive meaning, but also a cultural use of water, which is particularly important for indigenous population around the world. And with the heightening of water insecurity that this population have been facing and will be increasingly facing in the future, this means that many of these cultural practices that they put in place are actually at risk, and this makes them more vulnerable and puts them in a more difficult position when it comes to climate change adaptation. And with that, I think I'm done with my slides. I'm happy to leave the word to Aditi again. Thank you.
Thank you so much, Martina. Now I am also again very conscious about time, and we still have our climate resilient development Lisa's presentation. So I will just move through very quickly about some of the adaptation work that the working group 2 overall has done. Overall, we know what we know about adaptation is that we know that there has been a whole lot of literature on adaptation. We know that there has been adaptation happening, but we don't really know the actual extent of adaptation implementation. For example, this particular assessment did something called the Global Adaptation Mapping Initiative, which reviewed over 2,000 pieces of articles, but these are likely to be only a very small part of the overall adaptation action that may be happening. What I'm trying to say is that there isn't, even whatever adaptation is happening, we aren't documenting it well enough. Then a few others are documented adaptation. Whatever is documented, what we are finding is largely fragmented. A lot of them is happening in Asia and Africa. And majority of the adaptation, as I've already said, are happening due to in response to water. Then adaptation is local, as we all know. And the most, I thought, important finding from the working group 2 was this entire absence of evidence on risk reduction. We know adaptation is happening. We know that adaptation has various benefits, but what we do not know is whether those adaptation are actually reducing risk. I think that's a question that we as researchers and practitioners actually have to grapple with. We have to do a better job of documenting adaptation and measuring effectiveness of adaptation in reducing risk, in knowing what exactly it means to reduce climate risk and what does it exactly mean for an adaptation to be effective, which is a bit more complex than mitigation effectiveness. Mitigation effectiveness is captured by, say, tons of carbon CO2 emissions reduced or removed, but adaptation effectiveness is a bit more complex because adaptation is also about vulnerability. So I think developing better metrics and understanding of that is quite important. In the water chapter, we found that, again, based on the GAMI database, that almost 60% of the adaptation was related to water. And again, our main finding was that there are various positive benefits of adaptation, income benefits, sometimes even ecological benefits, livelihood benefits, but the evidence is not that strong to say whether those benefits actually translates to risk reduction. Even more importantly, we looked at future adaptation. So I think there is a whole lot of study that looks at the effectiveness of future adaptation. And we were able to do whatever, I think some 40, 50 studies were available, and we were able to do a systematic assessment of the projected effectiveness. And our main finding there was actually pretty grim, that adaptation, anyway, right now we don't know how effective adaptation is. We know some adaptation is effective, some isn't, but we don't have a lot of evidence. But what we also now know is at a higher level of global warming, adaptation becomes even less effective. So water-related adaptation, many of these, so if you see in this part, these big red and orange blobs there are basically saying that residual risk after adaptation increases at a higher level of global warming. So I think that should be a matter of serious concern. And in some ways, mitigation and keeping temperature within 1.5 could be our best bet as of now. I don't want to go too much into the mitigation part of it. Also, we found in the water chapter and also partly in working group 3, which is on mitigation, that many of the things like carbon dioxide removal as well as other mitigation methods can have large trade-offs with water and food security, trade-offs that are not often discussed very carefully. For example, bioenergy crop. While bioenergy crops can limit global warming by weaning us off fossil fuel, but at the same time, it can increase water stress. So there are these careful trade-offs that we need to look at. Similarly, bioenergy crops can significantly impact food prices. Another very popular and justifiably so perhaps is around afforestation and reforestation. But this also, like where we do those interventions, where we do forest, what kind of forest, how are those forests managed, are just as important as, their mitigation benefits. So forests have to be seen as more than carbon. They are also about water. So one of the global assessments had said that afforestation and reforestation should be concentrated in water abundant location and where transpiration can potentially be captured downstream. So I just want to end here and pass on to Lisa, but and emphasize that water also has a role in mitigation, which isn't often very apparent. Yeah, over to you, Lisa. Lisa will talk about climate resilient development and the role of water, or how water can be a part of that.
Thanks, Aditi. Okay, so coming at the end here, it is an opportunity also to talk about what is essentially understood in the IPCC report as, to some extent, the solution, how to address all of these things that have been mentioned already. And climate resilient development is a concept mentioned already. Actually, Aditi, if you could go back, yeah, thanks. It's mentioned.
Sorry, I'm trying to unmute myself, mute myself, and accidentally changing your slides. Yeah.
If you could just go back to the previous one before, briefly. Yeah, thanks. So the climate resilient development is a concept that's mentioned in the Paris Agreement, and it's set out there as an objective for countries, not defined very well. It is in the report we have drawn together from previous IPCC reports and also literature, that climate resilient development represents a combination of climate action, so adaptation and mitigation, in a way that supports sustainable development. Now we can go to the next one, please. And so previous reports have identified this concept as development trajectories that combine adaptation and mitigation to realize the goal of sustainable development. Our contribution in the AR6 is to talk about how this is to support sustainable development for all. And that those two words, for all, are really, really important, because we're talking about trying to make sure that everybody on the planet is able to have a sustainable and livable future. And you might recognize these words, for all, coming from the Sustainable Development Goals. Next slide, please. So how does climate resilient development understood? I'm not going to go into all the details of this figure, which you can find among other places in the summary for policymakers of Working Group 2. But essentially what it talks about is these societal choices that cumulatively take us onto either higher or lower climate resilient development pathways. And that's essentially these choices that we've been talking about here in terms of water use, water management, and development. And so in the lower climate resilient development pathways, societal choices translate into maladaptive actions, into rising emissions, into entrenched systems and unsustainable development. But luckily there are multiple development pathways. And so we can see that, in fact, importantly, some of the choices that we've made in the past have meant that we no longer have access to all of the climate resilient development pathways that lead to high climate resilient development. And that's what this dotted line at the top here means. It's talking about the lost opportunities. And this is coming from past greenhouse gas emissions, past choices in development, colonialism, for example. Importantly, though, it's societal choices that are made on a continuous basis. And that means that we still have the opportunity to get ourselves onto the higher climate resilient development pathways. So this is basically, it's these set of diverse decisions that make up societal choices that potentially reorient, for instance, dry lands or other places toward climate resilient development by supporting deep system transitions. And the choices that involve transformative adaptation, mitigation, and sustainable development actions, they drive what we talk about 5 independent system transitions in energy, land, other ecosystems, urban and infrastructure, industrial and society transitions. And so obviously in this case, we might talk more about the land and water transitions. And so here, transformative changes include things that influence underlying values and worldviews, ideologies, structures, and power relations. And in addition to practices and technologies, and all of these are required to achieve the system transitions that would hopefully take us to higher climate resilient development. And next, please. So really, again, to emphasize that what we've been talking about here is about the many societal choices that we can make. And we talk about arenas of engagement. So it's in many different places that these choices are made. One example that I'm going to point to just in the interest of time to focus here is that, for instance, that the choices are made on multiple different levels. So it's really from the local to the global. And here you can think of local customary institutions of land and water resource management. And here these go from sort of on a local level, and then you have a more formal planning process, maybe that happens on a regional or an urban level, up to international policy negotiations. But it's in each case that there are opportunities to make choices that could influence whether we're heading towards higher climate resilient development. And for the next slide. Here, I just want to draw attention to additional key dimensions for climate resilient development that have been raised already. And I think one of the most important ones when we talk about, for instance, water management is thinking about knowledge diversity and how this can further climate resilient development. Knowledge diversity in, for instance, agricultural development or agricultural water management. And Martina has just talked about this with respect to gender diversity and also indigenous knowledge, and how important this is in making sure that we have that diversity of knowledge. Because if voices from all relevant and all affected people are excluded, we're less likely to find pathways that lead us to higher climate resilient development. So finally, just to conclude on climate resilient development, I think next final slide for me, please, Aditi. Thank you. So just to summarize, basically the picture is that climate resilient development recognizes that we clearly need to stop emitting greenhouse gas emissions. We've already heard about the way that increased greenhouse gas emissions leads to higher warming, and that has influence on limits to adaptation. But obviously we still need to work hard at achieving sustainable development in many places where there are big development gaps. Similarly, though, simultaneously, this development needs to be low carbon and it needs to integrate climate risk. So it needs to think about adaptation. And this is essentially what climate resilient development is about. And when we think about how water relates to this, we recognize that development strategies need to take the impacts of climate change on water into account, not just for adapting to flooding or drought or extremes, but also considering future aspirations for livelihoods and how water use, management, and availability relates to those choices. That's all for me.
Thank you so much. Thank you, Lisa. And I think we are quite well on time. So we can take questions from the audience. And did I have an additional slide? I think I'll just share. Sorry about that. Yes. I think this, I just wanted to show this, that this was basically the last sentence of the summary for policymakers that said that the scientific evidence is unequivocal. Climate change is a threat to human well-being and the health of the planet. Any further delay in concerted global action will miss the brief and rapidly closing window to secure a livable future. And I think one of the main objectives of this session was also to show that water would have an important role to play in that concerted global action. So with that, I think I can pass on to my other co-panelists if they have any questions, or I believe the questions are being posed on the other channel, which does anybody see questions? I'm not entirely sure how the questions are getting asked here, but
we have
okay, I see that
on the World Week, on the World Water Week webpage. There's a chat box if people want to put in their questions there.
Questions, yes, I see Vadim had asked something. Yes, good. Okay, so if there are questions from the audience, please feel free to put it on the chat box, and we will try and answer those. And otherwise, my co-panelist, because we were quite rushed and we had quite a number of presentations to present. So I think there is a time to add to what we couldn't say.
Can I ask a question to Lisa on her presentation just now? It's on the common interpretations of development, and from the perspective of someone in the global north. In the UK, the term development is often taken to mean this rather unhelpful term of developing countries. So you kind of there's developing and developed countries, isn't there, which is quite an old and perhaps not necessarily very helpful term. So climate resilient development may be taken to mean something that happens in so-called developing countries. But I think we're learning now that actually, and see what you think about this, that this is absolutely not the case. As an example, in the UK, just recently, a month ago, we had incredible wildfires, and because of the unprecedented high temperatures, 40 houses in London burnt down because of high temperatures causing fires which spread through gardens, and so on. It was a huge shock. Literally not the kind of thing that has happened in this country before. And climate resilient development, for me, would mean being more prepared for that kind of thing in a so-called developed country. Would you agree with that? With that view, should we be more encourage people to think about it in that way?
Yeah, just to jump in, I mean, there are others who can contribute to this as well, but I think the importance of it is exactly as you say. It's not about, we're not talking about the sort of development of countries in the global south only. This is also about development more broadly. There are many different ways of understanding the word development. Improvement might be the most kind of neutral way. I don't want to suggest at all that it's only growth. That was a kind of a paradigm that emerged from the 1950s after colonialism sort of started to ebb away. But I think I should say colonialism is still there in many ways, but many countries got freedom. I would say the critical issue, and I think Professor Salim Hook talks about this nicely, is that we actually have in the global north, there are a lot of lessons that can be learned from the experiences of the global south, and in many cases the global south has a lot more knowledge and experience that we certainly need. And it's true, rethinking all of sort of, and you can interpret climate resilient development as meaning essentially just better climate resilience. But it is about thinking really broadly, and that was hopefully what I tried to, in a rush, illustrate about sort of this very wide and integrated way of thinking about the future. It's essentially a way of thinking about the future that requires us to think both about sort of the climate action that we take. So for the global north, that will be mainly mitigation, but also obviously lots of adaptation as well, but also sustainable development, which is not at all only exclusive to the global south. So yeah, it is about the sort of integrated thinking about how to plan for the future.
Okay. So we have a few, Martina, you have your hand raised. And I see a question on the chat as well. Go ahead.
Yes, yeah, thank you. So I'm going to address the question that Nora asked, and actually I wanted to make a point following up on what Richard said and Lisa answered. One thing that I wanted to highlight about the report as a whole, and that I wasn't able because of time constraints to say in my presentation, is that this report is quite unique because it is the first report really that tries to integrate indigenous knowledge in the assessment of both impacts, vulnerability, and adaptation. And so while, you know, we've tried to do our best, and some of us are still frustrated about the quality and what we have put out, this is the best and the first attempt to do that in an international science policy interface as the IPCC is. And so to answer the question that Nora had in the chat in terms of is there a reason to be positive and optimistic? Well, first of all, we can say that you know, the amount of knowledge that we've taken into account and the diversity of knowledge that we've taken into account in this report is a reason to be positive and optimistic. We've enlarged the type of knowledges that we've taken into account, so that's a plus. And by doing that, we're also able to show that, for instance, indigenous knowledge, traditional knowledge, local knowledge are not things actually that are set in the past. They are knowledges that are highly adaptable, and that is actually a reason to be positive because it gives us a wider array of potential strategies to tackle climate change now and in the future. Thank you.
Thanks. Hi, Edmund, and then Richard.
Yeah, I can also build on what Martina just said. That's why we should keep being positive. We can see also that the knowledge is improving, the level of details, those kind of report offers is improving. And we see one of the innovation in this report is adaptation, feasibility, and effectiveness, which shows clearly that it's not because one adaptation option is working in Africa that it should be implemented or replicated straightforward in Asia or elsewhere. So this is a kind of powerful tools to support and guide policy mechanism on what, how we should include different dimensions, institutional, technological, economic, and make this assessment before making a decisions on which type of adaptations we should use. In the Africa chapter, we did this assessment. It happened at the continent level, and we expect that this kind of can be taken up and then also be used at different scales, national and even subnational. So I think we should be positive, and of course, also it's important to take action now and not delay further.
Yeah, no, those are very important points. I did think that the adaptation analysis, that assessment that this report has done was quite unique compared to the previous ones. And I want to add something about the reasons of hope, but I will first give the floor to Richard.
Thank you. Yeah, I'm really glad Nora asked that because it's probably the most important point at the moment, I think, in the current climate conversation. And every time I give a climate change talk to a public audience, I get asked, am I optimistic? These days, I say I'm motivated because, yes, we can still deal with this issue. It's going to be through a combination of urgent mitigation action, so urgently reducing emissions, and also urgent action on adaptation and improving resilience. But as Edmund says, we have to do this. We have to get on and do it. So I encourage everyone to feel motivated to make the positive change happen. So every person in this discussion now, I'd encourage you all to do what you can to make this positive change happen. Thank you.
Yes, thanks, Richard. So on another thing, I think now with the new pledges, which are still hopefully inadequate, but at least we have come to pathways that are taking us more to 2.7 to 3 degrees, which is still very, very bad, but not to 4.5 degrees that we could have. So I think there are those kind of incremental changes, but a lot more. Yeah, these climate pledges needs to become much more ambitious, and the gap between the ambition and the implementation. So for one, we have actually a couple of types of gap. One big gap is that the ambition is just not ambitious enough. It's still taking us to a 2.5 to 3 degree world, which is unlivable world for the majority of us. The second is that there is also a big gap between whatever ambition is being put on the table versus what is being actually implemented. So that's another huge gap. So it's not necessarily that what the government say they would eventually end up doing. And yeah, and for me, one of the major takeaways from this assessment has been actually this wake-up call that adaptation, unless mitigation happens simultaneously, unless we're able to limit warming within 1.5 to 2 degrees, majority of our adaptations simply won't work. And I think both Chandni and I, and for many of you, I think we have been facing these heat waves. And the question is, how do you actually adapt to a heat wave? How does a wheat crop, for instance, adapt to 50 degrees centigrades? It simply is not possible. How does a human body adapt to continuous wet bulb temperatures of over whatever 34, 35 degrees? That's not physiologically not possible. So I think we are hitting those kind of limits. And for me, the major issue is really very fast mitigation and also the flow of finance for adaptation in the most vulnerable countries. Yeah, Lisa.
I would just wanted to add another positive thing, because I think that in terms of the knowledge, what's come more, I think, really positive is that there's a huge amount more knowledge coming out from the social sciences, from the qualitative social sciences and humanities, that are helping us really understand and communicate the importance of the integration of climate action, that it isn't just a sort of standalone thing that addresses climate change, but the importance of looking at development and that process of whatever improvement and planning, and that's where we need to start looking. And it's not just sort of saying, oh, okay, you know, it's all about technology, we need to absorb carbon and so on. But the fact that we have a lot more spaces for this qualitative social science knowledge and the humanities knowledge to come out, I think is really positive, and that's increasing exponentially. So there's still some barriers to overcome to make sure that we actually have a way of integrating and doing sort of effective interdisciplinary research. But I think from a scientific perspective, the science itself is becoming not just more kind of confident about what it's saying, but also much more robust.
Yeah, that's true. So there was also a question around in the chat around whether insurance industry can contribute to this knowledge, to filling the knowledge gap of adaptation effectiveness. And I was wondering if Chandni or any one of you would want to take that, or Edmund.
I guess it's not my field of work, but at least the assessment that we did on insurance as an effective mechanism of adaptation, there are mixed outcomes really. On the one hand, of course, it can help people buffer themselves against risk, or if you do face loss because of a certain climate-induced hazard, then at least you can get some repayment to cover those losses, or damages rather. But on the other side, there's this whole literature, actually, again, from the qualitative social sciences, as Lisa is saying, which has nuanced that story, which is to say that often having insurance, risk insurance schemes creates this moral hazard where people might tend to feel that they're safe because if they are going to face a flood, they will get compensation for that. And they tend to build in, exposed areas that are hazard prone. So actually it has a negative overall impact on adaptation. So I think it's important for us to think about all of these strategies. They have their pros and cons, and that's what I think this assessment does quite well. Talk about those pros and cons for vulnerable people, at-risk ecosystems, and then also over time and space, which is what we call in some ways maladaptation or the unintended consequences of adaptation. So yeah, but I guess, I mean, if it's to fill a data gap, I think maybe the risk insurance industry has a space. There's so much to do on adaptation financing and costing of some of these damages, both currently and into the future. So there's a space, a definite space for that.
Yeah, thank you, Chandni. And I think in the Africa chapter, we clearly mentioned this as one of the adaptation options to consider, but it's also important that we should consider it carefully and then try to apply it in the way that it fits in the context. For instance, in Africa, where we see that weather stations, we have a huge gap on weather stations, and more than 45% of weather stations available in Africa can provide accurate data and to help people to make time decisions. So those kind of things we can see it's quite important. So we have the technology, we have something, but we should also think about how we use it carefully, how we create enabling conditions for this, and as Chandni said, how we use it in a way to avoid maladaptation. I see in insurance and farming systems is emerging in some of African countries, Senegal, Ghana. But we still have quite some challenges in other countries like mine, Benin, where we don't have this system at all.
Right. I was now wondering, we have now exactly 3 minutes left, and if all of the panelists, if there are no further questions from the audience, perhaps all of the panelists can take half a minute and say their final thoughts on what for them was the main takeaway from the IPCC working group 2, and what we should be looking at more deeply into the next assessment cycle of AR7. So maybe I can start with you, Lisa.
I think perhaps the critical thing is actually we know a lot and we know enough to be able to make good decisions almost everywhere in the world, and that we actually don't really need to wait for another report to be able to take action. Like, we can't afford to wait for another report, so action has to be taken now. And that's why we need to make sure that we support and vote for the politicians who are willing to take that kind of action, I would say.
Yeah, no, that's a great message. Martina?
Yeah, I can only agree with what Lisa has said, and maybe add that what is there more to look into? I mean, we see it every day in our daily lives, in the news. No need to wait for another report. The one main takeaway that I would say for me from the report was, like as we said before by panelists here, is that there has been a broadening of knowledge, a broadening of diversity and participation in the making of the IPCC report, both geographically and identity-wise. And that's maybe one thing that I look forward for AR7, for this diversity to actually keep on increasing. Thank you.
Thanks, Martina. Richard?
Thanks. So the key takeaway for me was that how strong the evidence is that we are seeing the impacts now. That was a big step from previous reports. We are seeing climate change having an impact around the world. It's quite obvious now. That's the key thing for me.
Yeah, true. Chandni?
Yeah, so I think some of the working group 2 coaches always say that this is the solutions report, this focus on adaptation and solutions. So I think we have a set of solutions. Some of them are working, some of them aren't. We know which ones those are. So we have a better sense of what's working, what isn't, what are the barriers. So really that a sense of urgency and the toolkit we have for these solutions is something that I take away, and that is hopefully a little more hopeful than constantly focusing on the risks and impacts, because I think that messaging has gone out. We've experienced it across the world this year, I feel. So it's really, I tend to always talk about and harp on the solutions from this report.
Yes, absolutely. Yeah, Edmund?
Yeah, and the report also clearly showed that adaptation should happen at the same time as mitigations and development. And yeah, so those things should not be isolated. And it's also important to consider people's diversity, and not the same solution should apply to everyone. And those are critical things so we can take away from this report.
Yeah. With that, thank you. We are dot on time. And thank you so much to all my fellow IPCC authors. I thought that this was we kind of covered a whole gamut of issues related to water, and including the problems, the risks, and the solutions. So with that positive note, I want to thank all our audience today, and please reach out to us, or just all these reports are online, so read them and take action. As Richard said, each one of us can do things to make a difference today and tomorrow. Thank you so much, and bye. Yeah. Thanks.
Thank you.
Bye, everyone.
Bye.